Hello everyone. In today's discussion, we shall discuss the generator of vector space. What do you mean by generator of a vector space and how it works with the examples? So first you look at the definition of a generator of a vector space. If you consider a non-empty subset S of a given vector space VF, then we call S as generator of the vector space VF if each element of V can be expressed as linear combination of elements of S. In other words, you say that S is generator of the vector space VF, and if V belongs to capital V, then there exists V1, V2, so on, Vn belongs to S such that alpha 1 V1 plus alpha 2 V2 plus so on alpha and Vn is equal to V for some scalars alpha I belonging to F, where I belongs to 1 to n. So look here very carefully. When you call a given set as a generator of a given vector space VF, here in this definition you see that VF is a vector space. Capital VF is a vector space and F is the field over which this vector space is defined. And S is the subset of VF. Now this subset will be the generator of VF if you can express every element in capital V as the linear combination of the elements from S. If it is possible to express every element in capital B as a linear combination of elements from the subset S, then you can certainly say that S is a generator of the given vector space. Now let us see one of the illustration. Here I have taken S with two elements. First element is 1, 1, 0, second element 0, 2, 0, 0. These are two elements in triplet form. Now I will show that this S will generate the subspace of R cube over R, which is given by W equal to alpha, beta, 0. Here you see that there are three things. One is the set, which contains two elements in triplet form, and here another set, W is equal to alpha, beta, 0. That is, third element is always 0, and first two element can be any real numbers. And third one, R cube over R. This is the complete vector space, and W is the subspace of this, and S is the generator of W. These things are given in the question. You have to prove that this S is the generator of W, and at the same time you have to prove that W is the subspace of R cube over R. So to prove this, what you have to do? First you have to prove that W is a subspace of R cube over R. And how you prove a given subset as a subspace of given vector space? For that you have to take two elements from the this field, and then you have to make a linear combination with the help of some elements in the W. If that linear combination belongs to W, then you will say that W is a subspace of R cube over R. It is very much certain that S is a subset of W. Why S is a subset of W? Because S contains the elements in this form. The third element is always 0, and first two elements are any real numbers. So it is obvious that S is a subset of W. Now I take two elements from W. First alpha 1 beta 1 0, which is denoted by X. Another one is alpha 2 beta 2 0, and it is denoted by Y. These are two elements from W. Now I will show that Ex, that is A into first element plus B into the second element, also belongs to W. What are A and B? These are elements from the field R. When you show how to show that Ax plus By belongs to W, let us see. The value of X is alpha 1 beta 1 0, and value of Y is alpha 2 beta 2 0. When you simplify these two terms, you will get this whole term. Here you see the first element somewhere here, second element is this, and third element is 0. Now what is the condition for an element to lie in the W? Third element should be 0. Here it is, and the first two elements must be real numbers. Now you see here, alpha is real number, alpha 1 is real number, A is real number, B is real number, alpha 2 is real number. Therefore their sum will also be real number with their products. Similarly, A is real number, beta 1 real number, and B is real number, beta 2 is real number. Therefore their sum will also be real number. Hence the first two element also belongs to the real number. Therefore this triplet from these three elements will give me an element from W. Therefore Ax plus By belongs to W. Hence W is a subspace of R cube. So I have shown the one part of the question, that is W is a subspace of R cube R over R. Now I will show that this is generated by S. For that, what you have to do? You have to prove here that every element of W can be generated with the help of elements from S. And at the same time, you have to prove that linear span of S is W. First, you have to keep in your mind that if S is a subset of W, then LS means linear span of S is also a subset of linear span of W. But you have to keep in your mind also that linear span of a subspace is always the subspace, that at LW is equal to W. Why it is so? Because W is a subspace. If W is not a subspace, then you cannot say that LW is equal to W. Now you take an element from W, alpha 1 beta 1 0, denoted by X. Then try to make a linear combination of elements from S. S contains these two elements. You make the linear combination of these two elements with the help of element L and M, for any scalar L and M. And when you combine these two elements linearly with L and M with addition sign and denote it by X, but X is nothing but alpha 1 beta 1 0. From here you compare the like terms, that is first element is compared with alpha 1, second element is compared with beta. From here you can get L value of L is alpha 1 and the value of M as beta 1 minus alpha 1 over 2. So you plug these two values in this expression, and then X can be seen like this one. X is equal to alpha 1 1 1 0 plus value of M is beta 1 minus alpha 1 over 2, and another element is 0 2 0. Therefore you have now expressed X as a linear combination of these two elements with some scalars but these are real numbers. Therefore you have expressed an element from W as the linear combination of elements from the S, capital S. That is, L is a linear combination of these two elements. Hence, X can belongs to now LS. LS is linear span of S. Therefore, W is a subset of LS. From equation 1 and 2, you can declare here that LS is equal to W. That is, the linear span of S is W. Therefore, W is a subspace of R cube over R generated by S. Now, for practice, I have given you a problem number 21. For that, I have given you a small hint. From here, you can develop your own solution for this problem. Thank you.